Hello. In last section, we have talked about what is mediation and what is moderation and how to differentiate mediation and moderation. So in this section, we're going to go deeper into mediation and how to do mediation analysis by using different methods. We have talked about mediation, and we know that mediation is actually a causal mechanism or a causal network. And we can see that it is actually a transfer mechanism because mediation actually explains the reason that X affects Y. It is partially or fully because X will lead to M first, the mediator first, and then mediator will affect the dependent variable, the Y. So it is like a transfer mechanism. And there are three very important concepts that we need to look at when we run mediation analysis. They are total effect, direct effect, and indirect effect. So the total effect of X on Y is like this graph. So when there's no mediator in the model, it will show you the total effect of X on Y by using the coefficient of X. So the total effect includes both the direct effect and indirect effect. And after we add the mediator in this model, you will see there are three new paths in this model. And path A can be indicated by this formula. So when we write the formula, it is M equals to AX plus an error item. So the A is actually the coefficient of X, right? And for the path B, it can be indicated by this formula, Y equals to BM plus C prime X and plus an error item. And the B is from the mediator and the dependent variable. And the C prime is a new coefficient between X and Y. So we call this C prime the direct effect of X on Y because we have controlled the mediator in this model, right? So it is the direct effect. And based on the total effect and direct effect, we can calculate the indirect effect. It equals the C minus C prime, or we can use the product of A and B to represent the indirect effect. How to do mediation analysis? There are basically three methods. The first one, Barron and Canning's 4 steps. It is a very classic method to do mediation analysis even now. And method 2, Sobel Test. So Sobel Test is actually to formally assess the significance level of the product of A and B, as we just talked about the path, right? So it is to test the significance level of this indirect effect. And for the last method, bootstrapping, it is a very popular method nowadays. And the macro process in SPSS is developed based on this method. And in the next session, we're going to talk about the three methods one by one. For the first method, Barron and Canning's 4 steps. For the first step, you need to show that there is a relationship between X and Y. So this is to estimate the path C, right? And the next step is to show there is a relationship between your independent variable, the causal variable, X, and the mediator. It is to estimate the path A by using this formula. And the next step, we need to show that there is a relationship between the mediator and the DV, the outcome variable. So this is to estimate the path B and the direct effect C prime. And in the last step, we need to judge whether it is the full mediation or partial mediation. So we can see this from the coefficient of C prime. So we can see whether it equals to 0 or not. If it equals to 0, it means that it is a full mediation. If not, we can call it a partial mediation. So please pay attention to this C prime equals to 0 because it is very different from significance testing. And according to Barron and Kenny, why they use this coefficient to judge whether it's a full mediation or partial mediation, it is because like if we use significance testing, even it is a very small coefficient, if the sample size is large enough, it can still be significant, right? If the coefficient is very large, if we only have very small sample size, this coefficient cannot be significant. So here we just directly use the coefficient or the pos C prime to see whether it is a full mediation or partial mediation. And for the 4 steps, if you want to conclude whether it is there is a mediating effect in this model or not, the very essential steps are step 2 and step 3. So for the first step, the relationship, the total effect of X on Y, it is not very necessary. So even if it's not significant, it doesn't matter. So the most important elements in these 4 steps are steps 2 and step 3. So this is to ensure that you need to have a significant path from X to M and then have a significant path from M to Y. Here it shows you how to do it in SPSS. So I guess you have learned how to do multiple regression in your last lecture, right? So this is to use your skills to do multiple regression or to do simple regression in SPSS to run these 4 steps. Here it is there is a simulated data set where you can download from your Canvas. So in this data set, there are 3 variables. The first variable, exposure to role models, is the IV. The mediator is the entrepreneurial self-efficacy. And the dependent variable is the entrepreneurial intention. Before we do the analysis, it is always a very good habit to know about your data by running descriptive statistics and to check the distribution of each variable. And here are the results and graphs of the 3 variables. So from the graphs, we can see that they are very close to normal distribution, right? So it means it is cool. It is very good to go. So why we need to check this like distributions and to check their descriptive statistics, it is because one of the most important assumptions of running regression analysis is like to ensure that each variable, they are normally distributed, right? So if they are highly skewed or they don't have a normal distribution, if you still run it, it'll give you a not very reliable result. And the first step is to run the regression of Y on X to estimate the total effect, right, of X on Y. So this will be very simple. You can just input this IV into this regression. And here it is the result. It shows that the coefficient of the exposure to role models on the like entrepreneurial intention is 0.423, and it is very significant, right? So to report this result, you can draw this graph, and you can add this label here, the coefficient of this path, and then you can add the significance by adding the asterisk here, 3 asterisks. And the next step is to run the regression of M on X to estimate the path A, right? This is also very simple by running a very simple regression. So the result shows that the coefficient of this path is 0.442. You can add a label here and it is very significant. The next step is to run the regression of y on x and m. So there will be two items here, right? So one is exposure to role models, one is entrepreneurial self-efficacy. So for this line shows you the direct effect of the IV on DV. So you can add a label here by typing in the parentheses. So this will be the number of C prime. And then for this line, it shows you the path B, right? You can add label here and add the significance level. So this will be the steps of running this regression. And in the last step, we need to interpret, and also we need to report the result, and also to see whether it is a full mediation or partial mediation. So by calculating this indirect effect, we can use the product of A and B, or we can use C minus C prime. So to report this result, we can say that the four-step mediation analysis shows that there is a positive relationship between exposure to role models and entrepreneurial self-efficacy. So this part, right? And then you can add this coefficient here, the standard error, and also the p-value. And then we will continue to say entrepreneurial self-efficacy, the mediator, is also positively related to entrepreneurial intention, the DV, right? After controlling for exposure to role models, which means we control the IV. And we also report this the parameters of this path. The coefficient is 0.471 and the standard error and also p-value. And then we want to say whether it is a partial mediation or a full mediation, right? So here we will say, as there is still a positive relationship between the exposure between the IV and DV after we control the mediator, this IV, this mediator's entrepreneurial self-efficacy partially mediates the relationship between the IV and DV, right? And then we can report this indirect effect. So this is how we do the mediation analysis by using the four methods. But as you can see from here, we can only report this indirect effect, but we still don't know the significance level of this indirect effect. So a very special case about this mediation is suppression. So suppression is it's like we have already said that step one is about estimating the relationship between X and Y, only X and Y. So this is a total effect, right? So the case is that X and Y may not be correlated. And also the sign of the product of A and B is opposite to C prime, which means the direct effect of X and Y is opposite to the indirect effect of X and Y. For example, the indirect effect of X and Y is positive. However, the indirect effect of X and Y is negative. So in this case, we will say that this mediator is a suppressor. Here is an example to help you understand this case. So normally we will think that the higher stress you have, the worse mood you will have. So there will be a negative relationship between the level of stress you have and the mood you have, right? And if we consider coping behavior in this model, this will change something, right? So it means that when we have higher stress, we're more likely to have more coping skills to deal with stress. So there will be a positive relationship between stress and coping. And also, the more coping you have, the better mood you will have. So here is still a positive relationship, right? So the indirect effect of stress and mood through this coping behavior will be positive because this path is positive and this path is also positive. So the product of this path and this path will still be positive, right? But initially, we will think that the stress, the direct effect of stress on mood is negative, right? So this will be the case of suppression. So it is a very special case. If you see this case, you can still understand as a mediation model, but it's very special. And as we just said that by using the 4-step mediation analysis, you cannot estimate the significance level of indirect effect, right? So that's why we have the method 2, Sobel test. So Sobel test, we also refer this as the delta method, and we use this to assess the statistical significance of this indirect effect, the product of A and B. And we use, actually, Sobel test is a very specialized t-test. So if you see this formula here, we have a null hypothesis, and we also have an alternative hypothesis. So the null hypothesis is the product of A and B equals to 0. So this is to see whether the reduction of the effect of X on Y after we include or after we control the mediation in the model will be different, right? Will be significant different. You can actually refer to this website. You can go to this website to input these figures. For example, A and B are the coefficients of the two paths, and SA and SB are the standard errors. So you can directly go to this website and input these values in the cells and to calculate the Z value, and it will give you a significance level. So here is an example from our previous 4 steps, the result from 4 steps, and you just type in these values in this cell, the coefficient of A and B, and also the standard errors of A and B, and then you click calculate. It will show you this t statistics and also the p-value. So we can see the indirect effect of this model is significant, right? However, there's a problem with this method, which is it has very low statistical power because we know that the distribution of A and B individually, they are normally distributed. But however, the distribution of the product of A and B will be highly skewed. So we will need very large sample size to increase the level of power. So this has been criticized by many scholars that because of its low statistical power, and that's why we are going to introduce you this bootstrapping method. So in bootstrapping method, it is a non-parametric method based on resampling with replacement. And so what is non-parametric method? So in non-parametric method, there will be no assumption about the distribution of the data. For example, when you run the regression analysis, it will require you to have a normal distribution of each variable, right? So when you run this when you use non-parametric method, there will be no such assumption. So the process of doing bootstrapping can be seen from the graph here. So just imagine that you have a bag of marbles. So you want the marbles have different colors, and you want to know the average number of, for example, the red marbles. So by using bootstrapping, actually you are creating many resamples by randomly picking the marbles and then calculate the average number of red marbles in each resamples. So the process is like, for example, you have a bag of 100 marbles, and you don't know how many red marbles are in this bag. And then you want to use bootstrapping. So the first thing you do is you create a resample based on your original sample, based on the 100 marbles. So what you do is you randomly pick one marble from the bag, and then you write down the color of this marble, and then you put it back, and then you draw again. So you repeat this process 100 times to recreate a resample with the same sample size. So and then you repeat the process like 1,000 times. So you will have 1,000 resamples. And in each resample, you can actually calculate the average number of red marbles, right? So in the end, you will have a bootstrap distribution of the average value of the red marbles, right? So this is the process of doing bootstrapping. And actually, some scholars have developed the macro to help you do this bootstrapping. So Hayes has developed the process macro in SPSS. You can go to this website to download this macro. Of course, if you know how to use other software such as R, you can always use the package called Lavant to do this bootstrapping, or to run this mediation. Or you can use M+. M+ is a paid software. You need to pay them to use the software. And also Amos. You can also use Amos to run structural equation modeling. So you can use other software to do this bootstrapping. And you can go to this website to download this process macro. And then you need to install this macro on your SPSS. So you can go to the extensions, utilities, and click install custom dialog, and you will see this new window here. And then you go to the folder that you just downloaded, and then you find this file called process.spd, and then you open it in this new window, and you will install this in your SPSS, and you can use this macro to do this bootstrapping. So to see whether you have successfully downloaded this or installed this macro into your SPSS, you can check from Analyze Regression. If you see this option here, process v4.2 is the version number by Andrew Hayes, then it means you have successfully installed this macro into your SPSS. So how to use this process in SPSS to do this mediation? So you can click this process, and then it will show you this new window here. And the first step is to specify the model number, the confidence intervals, and also the number of bootstrap samples. So for the model number, you can go to the PDF file. I sent it to you. It's called model templates for process. And in this file, you can go through this file, find the model that you want to test, and then put the model number. For example, it is model 4 for this simple mediation, right? So for this model number, you can select 4. So it means that you want to use this model. And then you input your X variable, Y variable, and also your mediator. And then you click OK, it will show you this result. So for the first part of the result, it is your model summary. It tells you what is your DV, what is your IV, and what is your mediator, and also your sample size. And the next part of the result shows you the result of path A from your IV to your mediator, right? So it gives you the coefficient, the significance level, and also the standard error. You can always report this in your final report, data report. And also you can find this standardized coefficient here. And next part shows you the dependent variable on your IV and mediator. So you can find the coefficients of the path B and also the C prime, which is the direct effect of IV on DV, right? And also the significance level, the standard error, and also the standardized coefficients. If you want to compare the coefficients between different paths, you can use this standardized coefficient. And for this part, it shows you this total effect. So total effect is only about X and Y, right? So it is a regression of Y on X, which is the path C. And you can see the coefficient, the p-value, standard error, and the standardized coefficient. So the result is actually very close to what we run by using the 4 steps. It's very close. And the next part is the direct effect, is the indirect effect, and also its confidence interval. So you can see from here, it directly gives you the effect, which is 0.2085. And also give you the standard error and also the confidence interval, right? So for this one, Boots LLCI, which is the lower confidence interval, and ULCI, which is the upper confidence interval. So you can see from here, you can always write like this using the square bracket to indicate the confidence interval. So to see whether this indirect effect is significant or not, you can see whether 0 is in this interval. For example, the range is from 0.1234 to 0.3045. So 0 is not in this interval, right? It means that this indirect effect is significant. And here you can interpret and report this result. You can draw this graph and add labels on each path, and also you can conclude that this is a partial mediation. What is the what is the indirect effect, and also you can always report the confidence interval.